Thanks for sticking around for my talk. Hopefully this will be worth your while. Okay, so I want to talk today about building systems, building AI for security systems. So basically applying AI to secure organizations. Okay. So so this is going to be a somewhat opinionated talk. Hopefully it'll make it more interesting. So I actually don't think that we're making as fast progress as maybe some other folks think here around developing AI cybersecurity capabilities. So everybody's seen this meter plot on the right, which shows that every 7 months, the task length that LLMs are able to do is twice as long at a 50% success rate. So that's amazing, right? So we're seeing huge progress in AI coding. But we can contrast that with this plot on stage right, which is from the GPT-5 system card, which shows that, yes, AI systems are getting better at solving sort of contrived capture the flag exercises, but they're not getting that much better at hacking cyber ranges. We're also finding, I sort of oversee the AI for security program at Meta, and I can say across the board, outside of coding, the LLMs actually aren't improving at that faster rate. But I think there's like sort of a paved. Actually, I'm going to talk a little bit more to this slide. There's sort of I think there's a paved road to building cyber capabilities into LLMs, and that's the road that the AI labs have taken with respect to coding capabilities. And so I'm going to talk about that in this talk, and talk about what I think we're going to need to do to actually get to the point where we can have autonomous agents making sensitive decisions on our networks, like detecting attacks and quarantining hosts or restricting access, taking actions that are dangerous with respect to organizational business continuity. But also necessary to take autonomously in a world in which attacks are increasingly automated by AI. Okay, and this isn't optional, right? So I think every speaker has referenced this Anthropic report about Chinese state actors leveraging Claude to vibe hack. Adversaries are going to keep sort of climbing the automation hill, and we're going to have to do the same for defensive security. There are a lot of AI for security products coming out that do SOC automation, that find bugs in code. But I really think we need to keep our eye on the prize, that our ultimate goal needs to be to actually automate, right? So if we stop at sort of Copilot level, like tools that find some bugs, and can propose fixes to those bugs, but it takes a human to review those fixes, that's too slow, right? As long as a human's in the loop, I think we haven't yet won. And the gains are incremental and sort of more quality of life. We really need to focus on full autonomy in our community, I think. Yeah, I mean, there's a lot of tools that are coming out around access management, right? Around using AI to sort of suggest who should have access to what. But again, I think we're not there yet in terms of full autonomy. Okay, so I think that we're going to have to solve for building really autonomous AI systems that actually, without a human in the loop, take sensitive decisions to secure our networks. I think this is going to be sort of more like building the models that live inside of a Waymo, which have been extensively tested, sort of very heavily empirically validated, and then also validated a lot in the real world. It's going to be more like building those kinds of models at scale, I think, that it is like taking models that were basically tuned for chat and sort of benign coding and applying them to security. That's where we're at today, right? Like most AI security startups are wrapping OpenAI and Anthropic and Google. I think we're headed to a future in which we're going to have to, in many cases, fine-tune our own models. Okay, so I'm going to make my opinions really clear and then hopefully substantiate them for the rest of this talk. So how do we get to meaningful autonomy, where we actually have autonomous systems defending our networks in a way that can actually counter what's likely to be a rise in autonomous cyber attacks? So one, I think this is a deep technology problem. I think we can only get so far in terms of sort of wrapping generalist models that are mainly targeting sort of chat coding and enterprise search use cases, which the generalist models basically are today. So I think that's going to take innovation at every level of the stack. And I think it's going to require specializing our models. But I think we're going to have an easier time in building that kind of autonomy because security is late in AI, right? So there's been a ton of work directed at AI software engineering, also at robotic systems like self-driving, Also in other domains which I think are relevant, like just sort of general multimodal pre-training on text and imagery and video. I think we can leverage a lot of that work, but I think we're going to have to do a lot of our own sort of deep work in this area. So I think that's going to involve, first of all, creating measurements, evals, that actually sort of allow us to index our progress towards building autonomous AI defensive systems, just like in other fields, right? So in AI coding, we have SWE-bench verified that are like basically the canonical sort of indices of progress around AI agentic coding. We're going to need the same kinds of evals. Some of them exist, but I think we have many more to build in terms of actually just knowing whether or not a new LLM is better than a previous LLM, for example. I think that, like I said before, we're going to need to fine-tune our own models. I also think that separate from the sort of technology piece, we're going to have to be aggressive in sort of reimagining organizationally how we do security, and I'll talk more about that at the end of the talk. Okay, so now I'm going to give like the maturity model that we're using internally at Meta around building increasingly autonomous AI security capabilities. So a lot of our engineering approach to building these systems is based on like the basic insight that machine learning models are just a different kind of technological object than traditional software. Basically, if you're building an agent that calls into an LLM and you change a prompt, there's really no way to know outside of an eval whether or not your system is better or worse, right? So if you're claiming that your system can automate investigations of alerts in your SOC, and an engineer comes along and like changes the prompt to add some more context or something. Right now, we're mostly in a state where it's just sort of like all vibes as to whether or not that actually works or not. And that's because the LLMs behave this non-deterministically and randomly, and they're sort of these opaque technological objects, right? So I think this is sort of like our current state in most of the security industry in applying LLMs. Basically, you've got a bunch of engineers, even within an organization and definitely across organizations, who are making claims about how well their agents actually work to solve security problems. But because there are no sort of canonical indices of how well like AI systems actually work in security, people are just basically asking them to trust one another. Okay, I'm going to skip over this because I feel like I talked to this slide enough. Yeah, and so I think like the way we're approaching this, at least at Meta, is like the sort of foundation of being able to make progress at all in applying AI to security are very good evals. And like a lot of times evals seem boring. Like it's much more fun, right, to say that you're using a multi-agent framework that coordinates 5 different LLMs and uses RAG and tool use, right? It's much more, like I think many people find it more boring to say that they developed like a very robust and heavily validated set of like canonical ground truth that allows us to actually measure how well an LLM is doing. But like you really have to do that boring piece to even know if this more fun piece is even improving anything, right? So across all of our AI for security work at Meta, well, I won't say all, but we're trying our best, right, to build those foundations first, so we can actually know whether we're making progress or not. I mean, I can't emphasize this enough. Like it's like if some new model comes out, like Gemini 3 or whatever, we just have no basis for even knowing if we plug that in, if it makes things better or worse, right? I mean, like you can't make a change to a system and into an AI system without evals and know if it's making things better or worse without having like actually very good evals that are high quality and uncontroversial in terms of their ability to index the problem. And so like, everything I'm saying isn't novel to machine learning as a discipline. The primacy of evals has been accepted in the ML community for decades, right? So, for example, in computer vision, ImageNet, machine learning engineers here, probably, if folks who have an ML background know about ImageNet, this was sort of like the operating system on which the computer vision community hill climbed computer vision from like 2012 up till the end of the last decade. An enormous amount of work went into creating that data set. So ImageNet had about 1 million images. They had 49,000 mechanical work. Turkers labeled those images. The images were labeled multiple times, between 2 and 5 times, to make sure that humans actually agreed on the content of the images. And what that allowed was leaderboards like this, right? That showed which systems performed best each year in which they sort of updated the ImageNet data set. The ImageNet also allowed us to understand the human error rate in classifying images, but it gave us this kind of map of how well we were doing at computer vision, and we're going to need the same kind of thing in every domain in security in which as a community we're going to try to automate. And imagine functioning in a world in which we didn't know which of these computer vision models actually performed better, right? It would just be a bunch of people sort of operating on vibes, making claims about how well their system works, and that's actually our current state in most of security. It's also, in order to make progress in cybersecurity, ultimately we're going to need to pay the price to get really good data and to get data streams that are continuously updated with real ground truth around the nature of attacks, the nature of bugs in code, the nature of insider threats. So in coding, I can say, coming from Meta, where we work on our own LLMs, we actually pay large sums of money in order to get experts to give us annotated coding data. And that's the case across all the labs, right? So here, this plot is an estimate of how much all the major AI labs have paid for like expert human coding data, where humans have explicitly sat down in a terminal, right, and solved programming problems given to them by those labs. And like it's not so like our progress as a community on coding, it's not just a sort of downstream effect of scaling laws. It's actually the result of explicitly getting the data that we need to train those capabilities into our models. We're also going to need to build our own reinforcement learning environments, which is the hot thing in 2025, right? So for capabilities that the big labs are targeting outside of security, like coding and deep research, we have all sorts of reinforcement learning environments now in the big labs. And there's really no reason that we shouldn't be building those. Well, we have to build those in security if we want to train those kinds of agentic behaviors into our models. And yeah, these coding environments are really ubiquitous at this point. They just don't exist for cyber, just because it's not the focus of the AI industry. But in terms of achieving our own goals, we're going to have to build those as well. And there's like an enormous difference between doing that kind of RL training and not doing that kind of RL training. So for folks who read the DeepSeek R1 paper that came out in Q1 of this last year, I think that was a particularly striking result. So they took like a very well-trained instruction-tuned base like model, and so that model got about 20% on like a canonical math benchmark. But when they RL trained it, they sort of showed. This plot shows the sort of RL training process. Over 8,000 gradient updates, and by the end of the RL training, right, this model that had been getting 20% of the math questions right was getting 85% of the questions right. I think many cybersecurity problems are like this. They require reasoning and multi-step agentic behavior, and we're going to need to build RL environments for like alert investigation and deciding who gets access to what on a network, and fixing bugs in code and that kind of thing too. And I think RL is the way we're going to sort of get out of sort of futzing with prompts and just sort of like asking LLMs to comply with us in solving our security problems. Like ultimately, we're going to need to train these models to actually do a better job at solving security problems at the precision that we're going to need to get to autonomy. And a good thing about RL is that it's dramatically more data efficient than pre-training and supervised fine-tuning, right? So like there was a paper that made a splash on Twitter this last year showing that you could do RL on like a single math example or a single coding example, and then your LLM would generalize to lots of other examples, right? And I think there's lots of I think in cyber where oftentimes like attack data are really sparse, like there's an opportunity to take advantage of like a handful of examples and use reinforcement learning to get our systems to do well against new examples. Okay, so I want to sum up the sort of ingredients that I'm pitching as crucial to our success over the next 5 years or so in automating security with AI. So one, I think the foundation of making progress in our fields is really solid evaluation that sort of uncontroversial. It's so good that it sort of uncontroversially indexes progress towards AI autonomy. Without having our own sort of versions of ImageNet for the different problems that we need to automate in security, we're not going to be able to communicate with each other about the progress that we're making, or even know internally within our organizations whether or not changes to our AI agents are making our systems better or worse. I also don't think we should just be living off of the sort of downstream effects of what the big labs are doing around building models that are mostly targeted at sort of bigger businesses like coding, enterprise search, social chat, and this kind of thing. I think ultimately we're going to need to build specialized models in our space. Those models are going to need to live wherever we need to do security, so on endpoints, on production servers, in the cloud. And they need to be fine-tuned to solve security problems and using our own custom data and in reinforcement learning environments. Okay, yeah, so those are sort of the ingredients that I think are going to be necessary. Okay, so here's the maturity model that we're using at Meta around developing these capabilities. Okay, so basically every AI security project at Meta starts out in this kind of crawl state. So in the crawl state, somebody has an idea, like, for example, maybe they think that AI can automate threat surface model. So we do a thing at Meta where, like, if we're going to onboard a new service, like let's say we're using a new cloud vendor to do AI inference, our security team sort of models like what the surfaces are within that new area. So maybe somebody proposes, we can use an LLM to just automatically generate, a report on like which areas we need to cover as a security team. Usually that just starts out with somebody just hacking on their laptop. They don't have training data. They don't have evals. They're just kind of messing around and seeing if it works. Eventually, we sort of reach, so I think that's a useful thing to do, just to see if AI is an appropriate sort of tool for the job. But obviously, you run into the problem where you get multiple developers in the project, or even a single developer can't tell what's really working and what's not. So this brings us to the next state, which we call walk internally within Meta, which is this is the point at which we decide, okay, we're going to use AI to try to solve this problem. And then we build evals, and you sort of get a committee of people to help build the evals to sort of make sure that we all actually agree that doing better on the evals means you're doing better on the problem. And the cool thing about having evals is that suddenly you can get a bunch of people working in parallel, trying all sorts of different techniques. Doesn't matter what they tried. If they got a better score on your evals, like everybody takes that seriously, and you can do regression testing, and suddenly you're actually doing engineering around the agent. Yeah, so suddenly you're able to sort of operate in a more principled way. But like the inevitable problem with this walk state is that you're still sort of begging like an LLM to do your bidding that oftentimes wasn't trained to actually help solve the problem that you're trying to solve. Ultimately, you need, like, not for every problem, I think, but for many problems, you need to actually add fine-tuning, or at least have like retrieval augmented generation based on like custom data. So in this run state, which is the sort of final state of AI security efforts at Meta, we have like all the things that I'm advocating for. So we have continuously refreshed annotated production data that's sort of feeding back into the system, allowing us to update it. We have online A/B testing, so it's not just offline evals that we're running, but actually, we're seeing the system in production. Let's say finding and fixing bugs, granting access to people who are requesting access to sensitive resources, investigating alerts, and we can see feedback online in terms of how well the system is doing. We can do A/B testing, so we can deploy a new system and see if it's performing better online than our old system. At that point, we're sort of a mature operation. Okay, and so I think it's like really important that we adopt these engineering practices in building AI for security, because I think without following at least most of what I'm saying, you sort of just get stuck in sort of building tools that can only really be deployed as assistants, because we don't have the confidence to actually allow them to make sensitive decisions that are required to actually autonomously defend our networks. Okay, I've got 5 more minutes, so I'm going to go quickly through the last part of my talk. So I think that like there needs to be huge organizational, like, I think we need to think just as creatively organizationally about how we do security as we think in terms of the technology, given how important AI is going to be for our field. Yeah, I mean, so like, there's some pretty established processes, at least within Meta's security org, in terms of the way we approach code security, the way we approach detection and response, the way we approach security policy issues. And it's based on this very manual workflow that we do within Meta. I think that I actually don't feel like I really know what the right organizational form is going to be as we start automating more things with AI agents. But I think it's going to require some uncomfortable changes. So for example, we just deployed an initial version of an access management system at Meta that actually makes decisions about who gets access to what for a very limited set of resources. It took it took as much internal sort of political alignment to deploy that system as it did technology work, I would say, because Meta is an organization where people, well, like any organization, there was an expectation that humans were reviewing these sensitive access decisions, and so we had to design very careful empirical studies where we compared AI agents to human reviewers, and really showed beyond a shadow of a doubt, that the AI systems were performing at a better precision than the humans. And even then, there was a lot of discussion, But I think that's often going to bottleneck using AI to automate security. But it's really imperative that we're able to do that, because in many cases, AI capabilities may actually exceed human capabilities, but organizational processes may actually be standing in the way of actually being able to do that. And so being flexible and agile and fast moving there, I think, is going to be really important given the new environment we're going to be functioning in over the next few years. Okay, I think I'm going to skip over this just in the interest of time. Okay, so wrapping up, I'll just sort of reiterate the main theses of this talk. So I think there's an assumption in our community that we can just kind of wait till the next launch of flagship models like GPT-6 or something like that, and then there'll just be this that will benefit from just a rising tide of AI capabilities, and we'll be able to sort of prompt LLMs and they'll solve security problems for us. Actually, I don't think that's the case. I think in order to I think that's true for building copilots that can maybe boost our productivity by 10 or 20%. I think okay, got it. But I think if we want real autonomy, if we want, for example, a world in which AI agents are investigating 90% of the alerts in the enterprise to the point where a human doesn't even look at the alerts, and if there's a real problem, the AI takes action before a human even finds out, right? Like quarantines a host or blocks an IP range. If we want to live in that world, we're gonna have to get much more scientific. It's gonna look a bit more like Waymo than it is just prompting some generalist model via an API. And so that's going to mean evals. That's going to mean bringing in our own sort of data. It's also going to mean sort of unblocking organizationally the ability to actually deploy those systems autonomously. Yeah, I mean, it's a really exciting time, right? I mean, I think that the threat landscape, is, I think we're at the tip of the iceberg in terms, we're at the very beginning of the sort of coming wave of AI automated attacks. The capabilities we have right now are really exciting. I think the capabilities we're going to have over the next few years are going to be even more exciting. Yeah, so I think there's a huge opportunity to automate, and there's a huge competitive pressure with the adversary to do that. Okay, and I'll stop there, and I guess I won't take questions, but I'll take questions in the room upstairs. So thanks.